Have you ever just wondered how a simple idea in your head turns into something a computer can actually do? Well, today we're going to pull back the curtain on that whole journey. We're talking from a basic thought all the way to a program that's up and running. Let's dive in.
Yeah, seriously, how do you command a machine with billions of tiny switches inside? It sounds like some kind of tech magic, right? But the secret? It's actually way more straightforward than you'd think. It really just comes down to communication.
And, just like any good conversation or any big project, it all kicks off with a solid plan. Before you even think about writing a line of code, you have to know exactly what you want the computer to do and, crucially, the step-by-step instructions to get it there. So, that plan, that recipe, in the world of programming, it has a fancy name. We call it an algorithm. Now, don't let that word scare you. It's really just the blueprint behind, well, everything. Every app on your phone, every game you play, it all starts with an algorithm.
So what is it really? Think of it like a recipe for solving a problem. The most important rules are that it has to have a clear end. You can't have a recipe that goes on forever, right? And every single step has to follow logically from the one before it. No guesswork, no magic, just crystal clear instructions. Okay, let's make this super concrete. Here's a dead simple algorithm for adding two numbers. Look how clear it is. You start, you get the first number, you get the second number. You do one thing, add them together, then you show the result, and you stop. See? There's zero room for confusion. This is the kind of detail a computer needs to get things right.
All right, so a list of steps is great, but our brains are visual. What if we could actually see the path our logic takes? Well, that's where our next tool comes in. It's called a flowchart, and it's all about making that plan visual.
A flowchart is exactly what it sounds like. It's a chart that shows the flow of your plan. It uses a bunch of standard shapes and arrows to turn our text recipe into a kind of map. It literally shows you the path from the start of the problem all the way to the end solution.
And here are the basic building blocks you'll see. The ovals are your start and stop signs. The rectangles, that's where the action happens, like doing a calculation. And that diamond, that one's super important. That's a decision point, a fork in the road where the program has to make a yes or no choice. And the arrows, well, they just show you which way to go.
Okay, so we've got our plan and we've got our map. But how do we actually talk to the computer? We need a language it can understand. And for that, we're going to dive into one of the most important, most foundational programming languages ever created, the C language.
C is a true classic. It's been around since 1972, born at the legendary Bell Labs. It was originally built to create the Unix operating system, and because it was just so powerful and flexible, its DNA is now inside practically every modern device you can think of, from your laptop to your smartphone.
So why are we still talking about a language from the 70s? Well, because C is lightning fast and super efficient. It lets you get close to the hardware, giving you a ton of control over how the computer works, like managing memory yourself. But it's also portable, which just means you can take the same code and run it on all sorts of different computers. It's kind of the best of both worlds, power and flexibility.
Okay, enough talk. The best way to learn a language is to try and speak it, right? So let's write our very first program in C. It's a rite of passage for every programmer for a reason.
And here it is, the famous Hello World program. I know it might look like a bunch of weird symbols right now, but trust me, it's pretty simple once you know the rules. We're going to break down every single piece of this line by line.
So, you type this text into a file. Then what? How does it actually run? This is a super important step that a lot of people miss. Computers don't actually understand C. We write our code, the source code, and then a special program called a compiler acts like a translator. It takes our C code and turns it into machine language, the raw ones and zeros that the computer's brain, the processor, can actually understand and execute.
Now, for that compiler to do its job, we have to play by the rules of the language. We have to use the right grammar, the right syntax. So let's jump back to our Hello World program and take it apart to see how it works.
Okay, that very first line, include stdio.h. What's that about? Think of it like telling your program, hey, I need to bring in a toolkit. The stdio.h file is a standard toolkit for input and output. That's just a fancy way of saying it has tools for things like, you guessed it, printing text on the screen.
Next, you see int main. This is huge. Think of this as the main entrance to your program. It is non-negotiable. Every single C program must have a main function.
When you hit run, the computer makes a beeline for main and starts doing whatever it finds inside those curly braces.
And inside main, we find our action. Printf hello world end/n. This is a statement. It's a single command that tells the computer to do something. This is where our algorithm really comes to life. And see that semicolon at the very end? That is so important. It's like the period at the end of a sentence. It tells the compiler, okay, this instruction is done, move on to the next one.
But what about notes for ourselves or for other programmers? That's where comments come in. The code can get complicated, so we leave ourselves little notes. The compiler completely ignores anything after 2 forward slashes or anything between a /* and a */. They are 100% for us humans to understand what's going on.
All right, time for a little pop quiz. I'm going to show you a tiny bit of code on the next slide. There's one small but absolutely critical error in it. Let's see if you can spot it. Take a look. What's missing here? I'll give you a second. Think about the punctuation of C. It's probably the most common mistake every new programmer makes, literally everyone.
And there it is, the missing semicolon. Without that little guide, the compiler gets totally confused. It doesn't know the command is over. It's such a small detail, but it just goes to show you how precise and literal you have to be when you're giving instructions to a computer.
So, let's just recap everything we've covered. We started with an idea. We gave it structure with a plan, our algorithm. We mapped it out visually with a flowchart. Then we used the C language as our tool to communicate that plan, making sure to follow all its rules, like including our toolkits, having a main entry point, and ending our statements correctly.
You know, we've gone all the way from just a thought to a real working program, and it's all built on just a handful of simple, logical rules. The structure might be rigid, but what you can build with it, that's limitless. So it really just leaves one question. Now that you have these basic building blocks, what problem would you want to solve? What would you build?